In this video, we are going to look at capacitors in series and capacitors in parallel. Then we look at a network of capacitors and how we can get the effective value. Alright, for series connection of capacitors, the capacitors in series. This is series when they are connected end to end. Okay, this call is C1, C2, and C3. This is point A and point B. So, to get the effective value of these three capacitors in series, the value will be 1 over C, which is the effective value, 1 over C1 plus 1 over C2 plus 1 over C3. So this gives us the effective value of capacitors when they are in series. So let's give them values and see what we are going to get from that. Let's say C1 is 2 farad, C2 is 3 farad, and C3 is 5 farad. So let's look at the effective values, what it will be. So this will be 1 over C equals 1 over C1, which is 2, plus 1 over C2, that's 3, plus 1 over C3, that's 5. So LCM here of 2, 3, and 5 is 30. So we have 30 here. Have 30 here. 2 in 30 is 15 times 1 is 15. Plus 3 in 30 is 10. 10 times 1 is 10. Plus 5 in 30 is 6 times 1 is 6. So that implies that 1 over C equals, this is 25, that's 31. So that gives us 31 upon 30. And that gives us 0.97 farad. So the effective value of these three capacitors is 0.97 farad, which is lesser than the least of them. So for capacitors, when you connect them in series, their effective value decreases. It goes as low as lesser than the least one among them. Okay, so let's look at parallel connection of capacitors. Connected to this node, connected to this node. Call this one C1, C2, and C3. Their effective value, C, will be C1 plus C2 plus C3. Let's give them values and see what we have. Say C1 is 2 farad, C2 is 3 farad, and C3 is 5 farad. 5 farad. Then the effective value becomes C, which equals 2 farad plus 3 farad plus 5 farad, and that gives us 10 farad. So the effective value, C, is 10 farad. Now, for capacitor, when you arrange them in parallel, the effective value becomes bigger than the individual capacitors. And this is like the reverse of the connection in resistors. So we have to take note of that. If you are yet to watch our video on resistors, go to the channel and check our videos on resistors. We are now in good position to look at capacitor network. That is combination of series and parallel connection of capacitors. So let's look at them. For this, we'll call this C1, the first capacitor. Let's call this C2, let's call this C3, and let's call this C4. Now, when you observe C3 and C4 closely, you see they have common node, and that suggests they are in parallel. So we get their effective value for C3 and C4. So their effective value, since they are in parallel, let's call it C. That will be C3 plus C4, and that gives us 3 farad plus 3 farad, and that is 6 farad. So their effective value is 6 farad. Now I'm going to redraw the diagram for this circuit, and that will be for C1, for C2, then for the effective value of C3 and C4. This is A to B. So this is our C1, which is 2 farad. This is our C2, which is 3 farad. And this is the resultant or the effective value of C3 and C4, which I have gotten to be 6 farad. So that is C, which is 6 farad. All right, we're not going to look at the effective value of the three of them in series now. And going by our formula, 1 over C should be 1 over C1 plus 1 over C2 plus 1 over C, this C being the equivalent of C4 and C3. So when we substitute values, we're going to have 1 over 2 plus 1 over 3 plus 1 over 6. LCM here being 6. So we'll proceed. So we have 6 here. 2 in 6 gives 3 times 1, 3 plus 3 in 6, that's 2 times 1, 2. Then 6 in 6 is 1 times 1 is 1. And that gives us, this is 5, this is 6. So we'll have 6 upon 6, and that is 1. So when we invert this, C is 1 farad. So the effective value here for this network is just 1 farad. Let's look at the second example. This question came all the way from JAM, and it's from capacitor network. So let's look at how we resolve the capacitance between P and Q. Let's call this C1 as the first one, and C2 and C3. Yeah. So when we observe C1 and C2, notice that they are in parallel. And for capacitors in parallel, their effective value will just be C1 plus C2. This will be 2 microfarad plus 2 microfarad, and that gives us 4 microfarad. So the effective values of these two is 4 microfarad. Now, we're going to redraw this diagram from P to Q. So this is the effective of these two, and this is the C3, and this is our point Q. So for this, we have C to be 4 microfarad, and for this, that's our C3, we have 4 microfarad. So we're going to look at this. They are in series now, their effective value. Since they are in series, 1 over C should be 1 over C, this C, let's call it Ci, then plus 1 over C3. On substitution, that will be 1 upon 4 plus 1 upon 4. Okay, we have 1 upon 4, 1 upon 4, and that is similar fraction. So that gives us 2 upon 4, and that is 1 upon 2. So 1 over C is 1 upon 2, and that implies that C is 2. So C is going to be 2 microfarad. So the effective value for this network is 2 microfarad.